like at lesson 8, 9, or 10 at the very end. Why am I being thrown into a word problem? Well, it's because you're going to learn 3 other types of solving systems. And I want to pause after you learn the first type because we won't usually go into a ton of detail with graphing. It's not the most accurate way to solve a system, but it is a way. So we're going to take a little pause today before you intro the next way to solve systems. I'm going to show you that you can use graphing with a word problem, just like any other type of solving systems. You have 2 plants, plant A and plant B. Let's make plant A into a cool color. My 6-year-old son would say pink is the coolest color ever. He enjoys pink. Plant B is the second one. When you're solving a system, you need 2 equations. So I need to make something out of the information they give me into y equals mx plus b form. Let's take plant A's. They give you 2 pieces of info. 6 centimeters tall is the current plant. It's at a rate of 4 centimeters a day. Which of those 2 numbers, 6 or 4, is the initial value? Which one is the thing that starts out and happens once? Is it growing at 4 centimeters or is it 6? Jersey. That's your starting point. So let's put 6 in there, and it doesn't change by 6 every hour or every day. It just starts at 6 and goes from there. Then they take the 4, and 4 is the thing that's changing. So 4 is the rate of change. Usually you'll see like per day or centimeters a day. That's the rate of change. There's plant A's. Let's look at plant B. It's 10 centimeters tall, a rate of 2 centimeters a day. Uh-oh, I forgot to throw in the y equals. Peyton, do you have the equation for plant B? Okay, let me just clean up the top. Sorry, I'm going out of order. Cool. So you now have 2 equations you can work with. They want you to graph those 2 and find when the plants are the exact same height. If you solve a system, you're going to find when they occur to be exactly the same. But before we graph it, we have to label this thing because it's nice and blank. Y is here, x is here. Is the x value going to be the number of days or the amount of centimeters it grows? Is the x the days or the centimeters? Brady? What makes you say that? Beautiful. Y depends on x. Couldn't have said it better myself. If you flipped it around and tried to put the centimeters here, the number of days in your life does not depend on the the growth of the plants. Thank goodness, because my plants don't grow. And so if I went on in life depending on my plants, I would probably still be stuck at 1 week old. I myself would not grow if my growth depended on a plant. So let's do that correctly to make sure it actually makes sense. Number of days and centimeters. Or you could put plant growth. Sure. Yeah, Jersey. That is a great idea. So there's only 13 here, so let's go by 2. Count by 2s going up. 2, 4, 6, 8, 10. Sometimes they'll be tricky and you won't be able to fit it. If that's the case and you counted by 1s, just erase it. And I'm now counting by 1s because I said it. 18, 20, that should be enough. Days, I think we're okay counting by 1, Jersey, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, now that we found the x and the y, let's go ahead and label it so we have our variable. X is the number of days, and y is the centimeters of plant growth. Centimeter plant growth. Yeah.
Wait, for the one up, what was it the first, like the dark line, or because you started two above the dark line on the graph?
Right here.
Yeah, you skipped.
Yeah, this is 0. They have the dark line and another one that's kind of there. If you did put 0, 1 down, that's fine. I guess you could go that route. Cool. Now that we know the x and the y, I actually changed the y. I don't think it should be growth. Let's make it plant height, because the growth is going to be measured by the rate of change. The y is the total height of the plants. Growth, I guess you can argue, makes kind of sense. Cool. You have your setup, you have your equations. Let's graph this thing. Plant A would be up 6. That is your y-intercepts. What is the slope for plant A, Charlotte? 4 or 4 over 1. So from here, go up 4, go over 1. Make a line when you have what? Why did I make a blunder? Milo, explain more. Beautiful. Very, very common blunder that I did not make intentionally. You can add 1. Over 1, up 4. So this is 2, that's 4. From 6 to 10 is 4. Go over 1. Bless you. Thanks for catching that. There's the plant growth for B. Let's graph, or for A, excuse me. Let's graph B. Start up at 10 and go up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 from 10 to 12 is 2 over 1. Up 2 over 1. What is our solution to this system? Then we'll chat about what it means. What's the solution to this guy, Jersey? Okay, good. 214 is a special couple or a special friend group. They can go into the club 2x plus 10 and 4x plus 6. They're the only match that will work. But that is cool and all. It's a lot of numbers, but it's not asking for just the coordinate pair. It's asking for when they'll be the same heights. The number of days it took down here was 2. So it took 2 days. They will be the same height in 2 days. Which plant is taller in 6 days? A is definitely taller. It's going to be off the graph. Which one's taller in 1 day? B's a little bit taller. Yep. So this is what we found was when they're exactly the same, but they're going to be either taller or shorter on any other day that you find on the graph. Cool. Questions? Moving on. Example 2. Can you read this for me, please? Abby, at a local college. Ooh. They tell me the x and the y, which is kind of them. Write a system of linear equations to model the relationship for the intro course. Let's make it like y equals mx plus b. Find the number that is staying the same. What's the initial value? Finding the number that's changing What is the slope? 11 versus 3. Which number do you think would be the slope? Which one stays the same as the y-intercept? Turn and talk to your partner once you have a guess for which one goes where. Three, two, one. Okay, 10 more seconds. Hello? Great, thank you. Frankie, you are leaving. You can head to the office. You might want to glance at the video for the last half of this example. Okay, and then I want you to try, just go to Google Classroom. I'll put instructions there. What number would be repeating? Which one stays the same? Annalise, 11 or 3 is repeating? 3 more students enroll each year is your key. I agree with that. Let's put 3x. So they're growing, they are increasing, it's positive. 11 would then be the y-intercept. Advanced course is a bit trickier. It has 21 students enrolled. That's the initial value, and they drop by 2. What would that look like for the slope? Ashlyn?
I did y equals negative 2x plus 1.
If it's dropping, it's going down. They're not increasing. You have to lose 2 students. Make sure you have negative 2. And let's make our graph. This one is going all the way up to 21, so can we count by 2s? Let's start with 2, I guess. That one's years? For years or for... Really? Are you sure? Oh, because it's counting down. I didn't realize that. If you counted by 2s, raise your hand. Hands down. If you did 1s, raise your hand. Hands down. It's going to be the same answer, but you'll just see it. It's going to look slightly different. Okay, label the axes. They give us x and y. X is number of years, y is number of students. The number of students depends on the number of years. Number of years depends on number of students. Did I say that right? No, number of students depends on the number of years. Yes, it was right first. Once you have yours labeled, go ahead and graph it. 3x plus 11, 2x plus 21. Boy, I should have counted by 1s. If you counted by 2s, you might want to go back, but it's going to look kind of funky. Start at 11, which is halfway, up 3, 1, 2, 3, over 1, 1, 2, 3, over 1. Yeah, that's fine. And 21 minus 2x, start at 21. Oh, that's the start. Which way should I put my slope for this one? If it's negative 2x, Avery, what should I do from 21? Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Cool. Like that. Yeah. Give me a thumb up if you have something that looks kind of like that. If you are lost, raise your hand with a question. Cool. Okay, so now that you have your graph, let's chat about what it means. Which course has more students enrolled at the very start? Look at year 0, then year 1. Alexis. Advanced is way higher. It's at 21. That is blue. Advanced course is higher. Why did the two lines go in opposite directions? Jersey? Advanced class is dropping, so it's going a negative slope. What was the other one called? Regular? Intro course? The intro course is gaining students, which is kind of real life. When you guys get to college, or Sierra College even, you'll notice that the really like general courses are hard to get into because everyone has to take them, and they're like a little easier usually. The more advanced courses, like my wife just finished statistics, it was like she could choose whatever class she wanted to because everyone ends up dropping out, and she got in and had like a class of 5 students. So when you have advanced students, advanced classes, it's pretty easy to get in usually. What's the solution to the system of equations? What is the meaning? There's my solution where they are crossing. What's the answer for the solution? Give me a coordinate point, Jacob. Over 2 up 17. And what does that actually mean? Yeah, keep going. So in 2 years, they have exactly the same number of students. They have the same number of students. You could then use the graph to like predict in 20 years how many students the advanced class will have. It's not looking so hot for the advanced class and the advanced class teacher. I would look for another job if I were that teacher. You try this one. Luckily, this is not a real. That was not a real graph for our advanced class. This one is hip hop class. They have X and Y, and is one of them dropping? 10 people increasing. They're both increasing. Cool. You try this one for 5 minutes. Once you have each step done, check in with your partner because there is no answer. Yeah. Do you not have this? Half of it is. Yeah, I might just go ahead and use this as your like 0 right here. So just go 0, 1, 2, 3, 4, 5, and then go up from here. Ignore the little section that got placed on the other one. And then you can go up to 6 and 10. You could probably count by ones for this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 1 is probably okay. Sneaky, sneaky. Once you have an equation that works for hip hop and tap, check with your partner. Then graph it, check with your partner, then answer the questions.